Hey students, it's time to begin Lesson 4. This is Unit 5, Lesson 4, Student-Facing Tasks. Notice and wonder. What do you notice and what do you wonder with this graph? You can type in whatever you notice or wonder. There's no right or wrong answer. But I'd like you to type in an answer that uses the scale on either the X or Y axis. For example, I noticed the total time is 75 seconds. I looked at the Y axis, the label is time, and the maximum amount of time is, I guess it looks like 75 seconds. Another thing I noticed, the farthest distance is 200 meters because I looked on the x-axis and the label is distance from the starting line, and the farthest it gets is here, which is, looks like 200 meters. Please read the labels on the axis and the numbers on the scale. I'll read one more of mine. At t equals 0 and t equals 75, the distance is 0, d equals 0. Let me show those points. At t equals 0, the distance is 0. Excuse me. And at t equals 75, the distance is 0. Okay, look at the scale. Look at the axis. Maybe you can tell me when you notice the slope is increasing and when you notice the slope is decreasing. Type in your answer. I'm not going to type mine in, so I'll just do some mumbo jumbo and keep going. You must type in sentences though. Next page. On the next page, if you have the packet that I gave you, you'll see that this is activity 4.2, equations and graphs of functions. And you'll see the graphs of 3 different functions. Remember that we took notes and I taught you that you can represent functions with either a description, which is a sentence or a statement. You can represent functions with an input-output diagram, an equation, a table, and graphs. So in lesson 4, we're going to learn how functions are graphed. Before I even get into this, I'm just going to tell you what you need to learn from this unit, this lesson. You're going to learn that when you graph a function, you're going to put the independent variable on the x-axis and the dependent variable on the y-axis. I just want you to remember that right now. The independent variable is the input. The independent variable goes on the x-axis. And the dependent variable, which is the output, it goes on the y-axis. So let me just draw an input-output diagram again real quick. The input is the independent variable. The output is the dependent variable. I'm going to label that on my picture. Why don't you draw this if you lost your notes? You need to remember the output depends on the input. The input is independent of anything. When you write an equation, you start with the output. The output equals something with the input or independent variable. I described this really well in the notes for lesson 3 and 4. I'm just summarizing it here. You have to remember The dependent variable depends on what the independent variable was. In other words, the output depends on the input. Please remember, independent variable goes on the x-axis. Dependent variable goes on the y-axis. So if we had the equation of a line, y equals negative 4x minus 2, then you know x is the independent variable. It's the input. And you know y is the dependent variable. It depends on whatever x was. It's the output. Phew. Okay, now that you have these notes and you know what this lesson is teaching you, let's go through the assignment together. Look on your screen. It says the graphs of 3 functions are shown. A, B, and C. Graph A, graph B, and graph C. Match each of the following equations to one of the graphs. Equation 1, D equals 60t, where D is the distance in miles that you would travel in t hours if you drove 60 miles per hour. Actually, I already labeled it on the graph because I got started without you. But I can tell that this is graph B because if I drove 1 hour, it would be about 60 miles. If I drove 2 hours here, it would be about 120 miles. So by looking at a point on this line, I could tell that it matches this graph B. Equation 1, which on your paper is A, it matches graph B. Now, it's actually much better if you look at these yourself and don't just copy my answers. Try number 2 on your own. Equation 2 gives you Q equals 50 minus 0.4D. So which graph do you think that is? Well, it has this negative 0.4D, and you have a lot of experience with linear equations. You know that negative 0.4D will be the slope of the line, and it's negative. So the graph is going down. And you have a lot of experience with graphing now. You know that the constant term, 50, you know that's the y-intercept. The constant term is the y-intercept. So just by looking at the equation, you know it crosses the graph, it crosses the y-axis at y equals 50, and it has a negative slope. And that's what we see in graph C. One more to go. The next equation is area equals pi r squared, where A is the area in square centimeters of a circle with radius r centimeters. Okay, well, there's only one graph remaining. By the way, in this equation, pi is a constant term. Pi doesn't change. But radius, the variable, it is to the power of 2. So it's going to get larger and larger very rapidly. If the radius is 1, then this equation is pi times 1. But if the radius is 2, then the radius gets squared, and that's 4. So this equation is growing exponentially because it's to the power of 2. This line here is pi r squared. Go ahead and select it. Oops, I clicked graph C, but graph C was the second one. I meant to click graph A. Bum bum. Darn it, I lost all my points. Whatever, I don't care. Okay, let's go on to number 2. Number 2 says, Label each axis with the independent and dependent variables and the quantities they represent. Answer the question for all three graphs. So for all three graphs, you're going to label the axes and the quantity it represents. It says, draw your labeled graphs on paper, take a picture, and upload it using the upload icon. If you do not have the ability to upload an image of your work, type labeled graphs are on paper. First of all, let me tell you right now, you better not type that it is on your paper. If you're here in the classroom, that makes sense. But I cannot walk over and check your paper. You are not going to do that. I'll tell you what you can type, though. So if you want to draw them, let's see what they'll look like. I'm just going to label it right here, actually. Let's just label it right here on the paper that I gave you. If you don't have that paper, you can draw them. For graph A, the x-axis is the radius of the circle, and the y-axis is the area of a circle. So the radius is the independent variable, and the area is the dependent variable. And I know that because when I look at this equation, the dependent variable comes first. A equals pi r squared. A comes first. The area of the circle depends on the radius of the circle. So you can label this on your graph and then take a picture. Make sure you have area on the y-axis because that's the dependent variable. And make sure you have r, radius, on the x-axis because that is the independent variable. But if you don't want to upload a picture, let me tell you how you can type this in. Do not tell me that it is on your paper. Don't type that in. You can type like this. Y-axis is the area of the circle because that is the dependent variable. The area depends on the radius of the circle. Then you can tell me what is the x-axis. What will you have on the x-axis? X-axis is the independent variable, which is the radius of the circle. You must explain it to me. Do not type graph is on the paper or something like that. I will not give you any points. You have to show me that you watched the video, you understand what's going on, you know that the independent variable goes on the x-axis and the dependent variable goes on the y-axis. Remember, the dependent variable depends on what the input was. The input goes on the x-axis. Make sure that you took notes on my videos for lessons 3 and 4 so that you learned that very well. Okay, next one. For graph A, what is the output when the input is 1? Look at graph A. What is the output when the input is 1? That means the radius is 1. Then the output is 1 squared is 1. It should be pi. I want to answer pi. Can I type it in like this? No? 3.14? I'm not sure how I should type in pi. Oh, I got it, 3.14. It didn't say to type in pi like before. What does this tell you about the situation? and then label it on the graph. What does this tell me? It tells me, okay, it tells me that when the radius is 1 centimeter, the area is 3.14 centimeters squared. You can use this caret for to the power of 2 centimeters squared. So that's what it tells me. When the radius is 1 centimeter, the area is 3.14 centimeters squared. It says label the corresponding point on the graph. Draw your graph on paper, take a picture, and upload it using the upload icon. Then it's incorrectly says, and I hate this, if you do not have the ability to upload an image of your work, type graph is on the paper. Don't you dare. If you cannot upload a picture, then you will explain it to me when you type it. So I'm going to draw the point on my graph. This is where the radius is equal 1. And if you look at the y-axis, that should be 3.14. If you don't want to upload a picture, you have to explain it to me. It is the coordinate point x equals 1 and y equals 3.14. Or you can put it in coordinate points. X equals 1, comma, y equals 3.14. Tell me the coordinate points. Do not tell me it's on your paper. I cannot come over and look at your paper. Next problem. Okay, for graph B, what is the output when the input is 1? Look at graph B. What is the output when the input is 1? Remember, input is x-axis. So when t equals 1, that means we have drove a distance of 60 miles. Because the equation is d equals 60t right here. Remember that graph B is the first one. It's a little confusing. If you're only looking at the computer screen and you didn't have your paper, you'd have to scroll back up to figure out what graph B was. All the way back. Graph B is here, and then you'd have to find the equation. That was equation 1. So write that down on your paper if you need to. I don't need to because I have the worksheets. For graph A, yeah. There it is. Okay, what is the output? 60. What does this tell you about the situation? Okay, if the input is 1, that means after 1 hour, we have driven 60 miles. Oh man, my spelling. You know what? I'm going to change that because I can't even spell correctly. Traveled. I know how to spell it, but the problem says traveled. There. If the input is 1, that means after 1 hour, we have traveled 60 miles. I don't mind if you copy my answers because at least I can see you're following along. But I'll be more impressed if you write it in your own words. Okay, let's see. Label the corresponding point on the graph. I did right here. Why don't you try uploading a picture? Take a picture with your computer's camera. It'll save in the picture file. Then come here, click on the 3 dots, click on the picture icon. It wants you to upload the picture. You have to click on the upload button. Then you can choose the file. If you click there, then go to the picture file on your computer and find the picture you took. Or you can type in the point is x equals 1, y equals 60. Just put it in x equals x. X equals 1, comma, y equals 60. You can give me your answer in coordinate points. Next problem. For graph C, what is the output when the input equals 1? Okay, for graph C is Q equals 50 minus 0.4D. If the input is 1, then that's 0.4 times 1. 50 minus 0.4 times 1 is 49.6. I just did the math in my head. I want you to do it on your paper, though. I should have said that. What does this tell you about the situation? It tells me that when D equals 1, Q is 49.6. Easy. Okay, let's label the point on the graph. Either take a picture or actually draw it. It's right next to the y-axis right there. Let me zoom in. Here's that point. You can draw it on your paper. You can label that coordinate. It's x equals 1, y equals 49.6, or just type in the coordinates. Coordinates. There we go. The coordinate is 1. There we go. Remember, when you type in coordinates, please don't forget that the x coordinate comes first in the parentheses, x before y. Okay, then it says, find 2 more input-output pairs. This is for graph A. For graph A, here, find 2 more input-output pairs. What do they tell you about the situation? Label the corresponding points in the graph. Draw a graph on paper. Take a picture and upload it using the upload icon. Okay, you can label 2 more points. How about when radius is 3, or when radius is 2, or radius is 3? And then get your calculator. I'll get mine. I'm not sure if it's going to show. It doesn't show on the video, so let me just get my cell phone. Okay, if the radius of the circle is 2, and remember, if you turn your iPhone sideways, it converts to a scientific calculator. So if the radius of the circle is 2, then pi times 2 squared. So 2 squared is 4 times pi. Oh no, where's my, there it is, pi is right down here. Ding! I thought it was going to multiply, but it didn't. Let me see if I can do this. 2 squared equals 4 times, it's not doing the order of operations that I want. I'll start with pi times 4, 12.56. Okay, you cannot type graph is on paper, but you can explain it to me. When the radius is 2, the area is 12.56. And when the radius is 3, the area is, and then do the same thing right now. Just do, if the radius is 3, what is it? 3 times 3 is 9, so that's 9 times pi. Every time I touch pi, it does pi. It doesn't even let me do the math. So hold on, start with pi. Start with pi times 9. 28.27. Okay, do not tell me there's a graph on your paper. You know you're going to get it wrong, but you can explain it when you type it in. Okay, for graph B, same thing. Find two more input-output pairs. What do they tell you about the situation? So same thing. For each graph, you are telling two more points on the line. Those are called the input-output pairs. So for graph B, well, we've already looked at t equals 1. Let's try t equals 2 and t equals 3. This one's easy because it's just 60 times t. I can do it in my head. In fact, I'm not even going to type a sentence. Let's just make it easier. T equals 2, d equals 60 times 2 is 120. And t equals 3, distance equals 60 times 3, which is 180. So now you've told me two more points that are on this line, this function. Same thing for graph C. Let's do 20 and 40, 60, 80. What do you want to do? It's up to you. I'm going to label these variables real quick just to help me. This is D, this is Q. The input is D, that's the independent variable. Q is the dependent variable. Okay, so if Q equals, not Q, if D equals 10, then Q equals, just a minute, I want to write the equation a little bigger to help me. 50 minus 0.4 D, because this one I actually have to do the math. So if D equals 10, then that's minus 4. 50 minus 4 is 46. And I'll do another one. D equals, how about 60? D equals 60. Then Q equals, it's going to be 60 times 0.4. That's 24. So I need 50 minus 24. 26. You can go ahead and do whatever numbers you want, but you have to get the math correct. I'll be more impressed if you do different numbers than me so that I know you really did it yourself. Phew. Okay, we're on to the next page. Not this page. If you have the packet, it doesn't have the "Are you ready for more" problem. Keep going. Activity 4.3, running around a track. It says, Kieran was running around the track. The graph shows the time he took to run various distances d. The table shows his time in seconds every 3 meters. Okay, so here's a description. Here's the graph that matches that description. It tells you that the graph shows the time t, and I see it on the y-axis. I'm just labeling things so that I can do the problem easily. T is here, and D is the x-axis. Okay, ready? Now let's answer the questions. Oh, they give a table of information. How long did it take Kieran to run 6 meters? Okay, look at the table here. When the distance is 6 meters, it took 2 seconds. Can you see that? I'm going to circle it and make sure that you're not just copying me, but look. When the distance equals 6 meters, it took 2 seconds. And you can see that on the graph too. I'll point it out. When the distance is 6 meters, it took 2 seconds. You can either look in the table or you can look on the graph. How far had he gone after 6 seconds? Okay, so let me just point to my paper this time, but you can look on your computer screen. After 6 seconds here, how far had he gone? Right here, 18 meters. So here is 6 seconds on the y-axis, and I just follow that over where it meets the line, and then I look down at the x-axis to find 18 meters. You can also see that in the table. At 6 seconds, the distance was 18 meters. Next, estimate when he had run 19.5 meters. Well, 19.5 is somewhere between 18 and 21. And on the graph, that's somewhere between 18 and 21 would be like 19.5. It'd be like right here. Maybe that's 6.7 seconds, maybe? Not, it's less than 7, but more than 6.5. So I guess 6.7 seconds. Please put seconds in your answer so that I know you're following along. In fact, let's go ahead and type this answer a little bit better. Estimate when he had run 19.5 meters. So let's make a sentence. I estimate that it took him 6.7 seconds to run 19.5 meters. There's a nice answer. And submit it. Estimate how far he ran in 4 seconds. Well, somewhere between 3 and 6 seconds. Maybe 4 seconds is right here. And that's somewhere between, oh no, I read the wrong axis. Between 4 seconds is here. I'm so sorry. Look at that. I hope you caught that mistake. I read the wrong axis. 4 seconds is here. So I go over, and then it's somewhere between 15 and 12 meters. I'm going to guess that's about 13 meters. He ran about 13 meters in 4 seconds. If you disagree, if you can read the graph even better than I can, please put in your answer. If you think it's not 13, but maybe it's 12.5 or 13.5, if you can draw your line really straight and read it better than me, go ahead. Is Kieran's time a function of the distance he had run? In other words, does the time depend on how far he ran? Let me think about that. Well, the farther he has to run, the more time it takes. So I guess so. The farther he has to run, the more time he takes. Let's read the statement again, just to double check. The graph shows the time he took to run various distances. The table shows his time in seconds every 3 meters. Yeah, I guess so. Every 3 meters, his time increases. So the time it takes depends on how many meters he has ran. Explain how you know. Okay, I'll explain that. The time it takes depends on how far he ran. Increasing distance takes more time. So, time depends on distance. Next problem. Oh, we have a new graph. Okay, go to the next page in your handouts. You know what? I just noticed the time, so I'm going to finish this one in video too. I want to get going home before I'm locked in the building. Please go to video 2. See ya.